Hello everyone, let's discuss a very interesting problem of code force, and it is of educational code forces around 126 rated for div 2, and the question number is C, water the trees. Okay, so we have been given n trees in a park numbered from 1 to n, and we have been given the initial height of each of the tree denoted by hi. Okay, so we want to water this tree so that, and our task is to grow all this tree to the same height h. Okay, to the same height, whatever is it will be the height. Let's see further. And the watering process goes as follows. Okay, you start watering trees at day 1, and during the jth day, you what you can do is that choose a tree and water it. If the day is odd, then the height of that tree that you have chosen will increase by 1. And if the day is even, then the height of the tree you have chosen increases by 2. Okay. Or second thing, you just do not water any tree on that day. Means skip a day without watering a tree. Means on each of the day you can do either of these things. Note that you can't water more than one tree in a day. You just have to water only one tree in a day. Okay. Your task is to determine the minimum number of days required to water the trees so they grow to the same height. Okay, and let's see the input pattern. We would have been given the number of test cases t, then the number of trees n denoted by n, and then we would have been given the height of each of the trees denoted by h1 to hn, where hi is the height of the ith tree, and that's all. uh, we have to output print one integer, the minimum number of days required to water the trees so that they grow to the same height. So first thing which comes to your mind would be, what would be the common height, means to which height I would grow each of the trees so that all have the same height. What will be that height? Okay, so how to determine that? Obviously, one can think of that can be the always the maximum height, maximum of all the height present. Okay, obviously it's quite obvious that this comes to our mind, and it is true also. But there can also be another case I will discuss later. Let's first discuss this example. Okay, it is head is given 2 1 2 4. Okay, so the maximum height is 4 here. On day one on day one, what I will do on day one, that the tree which I will choose will increase its height by 1. Okay, so let's choose this only, so it will become 2. Okay, I have used one day. Now on the second day I will choose this tree, and it will become 4. Okay, so I have used another day. Now on the third day, again the height can increase by only 1, so it would become 3. Okay, I have used another day. But now just wait, if I just choose this tree once again on the fourth day, its height will become 5. Don't you think so? So that's not an optimal solution, because the answer is here 4. Here is answer 4. So let's see how it has been done. The initial state of the tree is 1 comma 2 comma 4. During the first day, let's water the first tree, so the sequence will become 2 2 and 4. Okay, 2 2 and 4. Now during the second day, let's water the second tree, so the sequence of the height becomes 2 comma 4 comma 4. Okay, 2 comma 4 comma 4. Let's skip the third day. Here I miss one thing. We can skip also, so I will just skip this. On the third day I will skip this. On the third day I will skip this, and on the fourth day I will use the second type operation, which will increase its height by 2, so it will again become 4. That's what I wanted to tell you. Okay, so now it has become 4 4 4 of each, all the tree will become of height 4. So yeah, uh, that was quite obvious that we would always take the maximum height as our common height. Okay, but there can be a case where this might fail. Let's discuss that case also. Okay, suppose the heights is like this: 2 2 2 2 and 3. Okay, so on the first day what I can do, I will increase its height to, suppose I choose this only. Okay, so its height will also become 3, and I have used one day. Okay, now on the second day I can't choose any of these. Why? Because if I choose, then it will become of height 4. Okay, so let it go. But since the day is passing, so I will have to count that day also. Okay, now on the third day I will again do this 3. On the fourth day again I will have to skip. On the fifth day I will have to choose, and this will become 3. On the sixth day again I will have to skip. Okay, and on the seventh day this will become 3. So it had taken me 7 days. Okay, it had taken me 7 days. Can we find another solution where I would just require less than 7 days? Yes, let's see that also. Suppose this was the example: 2 2 2 2 and 4. Okay, it was 3. Let's decide to not make the common height as 3 but 4. Let's observe for this what I have done. It was 3. Okay, so on the first day I will make this as 4. Okay, I have counted one day. I have counted one day. Now on the second day I can increase it to 4. Okay, on the third day I will use another day. Now on the third day I will make this as 4. Okay, on the fourth day I will just make it as 4. On the fifth day I will make it as 4. I will make it as 4 on the fifth day. And on the sixth day, since it is an even day, I can increase its height to 4. So yeah, I have found another solution which will give the solution in 6 days. Okay, so this was an edge case. So I can prove that either the answer I will get optimal answer from maximum, which I denote with mx, or either mx plus 1. Okay, now you tell why not mx plus 2 or mx plus 3. Suppose if I try for mx plus 2, then obviously there was another option to skip a day, If I just go for the mx plus 2 height, obviously I would have performed another operation of plus 2. Okay, so why not just skip that day? If I require to just add plus 2 to to obtain the answer for the mx plus 2 height, then why not just skip that plus 2 operation and just obtain it for mx height? Just try to understand yourself. If I was able to do it for mx plus 2, okay, mx plus 2, then why not just skip the plus 2 operation once and just do it for mx height itself, okay? That why it the answer will always be provided either by mx plus 2 or mx plus 1 or mx. Okay, so yeah, let's move on to the solution now. So how to count the days? Suppose if I decided that the common height will be mx, if the height will be mx, okay. So one part is done. Now how to determine the minimum number of days for this mx height? Suppose you have been given n days, then what will be the number of odd days and what will be the number of even days? Obviously the number of even days is n by 2, means floor value, and the number of odd days will be n plus 1 by 2. Why? Because I would have to take the seal value. Consider the 5 days example. Suppose if 1 2 3 4 5, if it is even then it's okay, the number of odd and even days would be same, that is n by 2. But what if the number of days is odd? Then the odd value would be n plus 1 by 2, you can see here, and the number of even days would be n by 2 only, that is 2 and 4. Yeah, okay. So now what one thing you should note here is that it is some kind of monotonic in nature. The function is somewhat is of monotonic nature. How I can prove this? Suppose if I can do this watering, means growing the trees to the same height in suppose n days, then can I not make the height in some days greater than n, some number of days greater than n? Obviously I can, but I am not sure about n minus 1, n minus 1 number of days. Okay, whether I will be able to grow all the trees to the same height in n minus 1 days or not. But I am sure about, if I am sure about n, then I can also be sure about n plus 1 that I will do this. How? Because if I was able to do this in n days, so I can just skip the other days or in some other days. Okay, so that's where I got the intuition for the binary search here. Okay, so now the final let's move on to the final solution. Okay, so n by 2 is the number of the even days and n plus 1 by 2 is the number of the odd days. Since we know that in the even days we would add by plus 2, okay, and in the even days we would add just by plus 1. So why not? So it would be more optimal to just to use this plus 2 first. Means I would just use first plus 2 operation as max as possible, and then we'll try to compensate, and then to try to compensate the heights by using operation 1, means adding plus 1 to the heights. Okay, if I am able to do this, suppose for the height h, suppose for the height h, then I will go for the h minus 1. I will check for the h minus 1 because we have to find the minimum number of days. Sorry, it was not h, it was suppose I was able to do it in d days, then I will have to check for the d minus 1 days. Okay, I will have to check for the d minus 1 days, and if I was not able to do with d days, then obviously I would have to increase the number of days, that is d plus 1 days. So that's what we do in the binary search. So let's move on to the code part. I have explained it enough. So yeah, I have already taken the input. First I would have to take that number of test cases, then n, say input t, then while t minus minus, c input n, then vector in, a will denote the height of each of the trees, okay. So one thing I forgot, let's maintain mx variable also for denoting the maximum height. Mx denotes the maximum height of the tree. Mx is equals to max of mx comma a of I. Now I will create a function int, and suppose I create a function solve, which will return the number of days corresponding to the height h. Okay, so the what I explained, either the height would be mx or mx plus 1. Okay, a n, then mx I would have passed, and let's store it in answer 1. answer 1, int answer 2 is equals to solve of a comma m comma mx plus 1. Now I will just simply see out minimum of these two, answer 1 comma answer 1 comma answer 2. Okay, so let's create the solve function. I would say just this will take the first the heights, okay, a, then int n, and then let's say denote it as height. Okay, now I will perform the binary search. I will perform the binary search. uh, there can be, if suppose all the height was previously equal, then obviously the low can be 0, and high can be what, the difference between the sum of the differences between the common height and the all the other heights. Okay, so for the safety purpose, let's take it as high as possible, mid, and answer is equals to 0. Now while low is less than equals to high, while low is less than equals to high, mid is equals to low plus high minus low by 2, means mid is the number of days, mid is the number of days I am checking for. Okay, if mid is the number of days, then what would be the number of add one operation? Let's increment by 1, it would be mid plus 1 by 2. Okay, and increment 2 would be mid plus mid by 2 only. Let's name it as add 2, because the code I will provide it, it is having the variable name add 1 and add 2. Okay, so now for int I is equals to 0, I less than n, I plus plus, I will just first of all try to assign the add 2 operation. I will just try to do add 2 operation. Okay, so int d is equals to common height. What is the common height? H minus ai. Okay, so number of add 2 operation required is what? It will be add d by 2. Suppose the difference was the difference in the height of the common height and the height of this tree was 5, and the operation I am performing is of type 2, so obviously I can perform only at max 2 operation. Why? Because if I have performed 3, then it would have become surpassed this height. Okay, it had become 6. That's why I am taking floor value there. Okay, so now if add 2 is less than required value, means now we don't have the uh, we either have the same number of as I have required or either less than that. So in that case, add 2 would become 0, and it doesn't make sense to move further because I can't perform the operation of type 2 further. Okay, break, and before that I will just have to ai plus equals to since I am performing add 2 number of times, so it will be add 2 into 2, because each time I will add height 2, and how many number of times it is add 2 times. Okay, so yeah, if it is not so, means requirement is less than add 2, requirement is less than add 2, then I will just say add 2 minus equals to requirement, and a of I plus is equals to requirement times into 2. Okay, so that's all about. But one thing you should notice here, that each time when I perform this binary search, I am also modifying this array A. So for the next time, when this mid is changing and we are checking for each of the mid, so I will also have to So we will have to start with the same height as was initial, as all the cases are independent. Okay, so I will have to maintain a copy of it. Okay, and each time I will just say a is uh, after the completion. Let's We will do that. Okay, so now we have performed the operation of type 2. Let's name bool of k is equals to true, means I am assuming that I can perform the operation, means make the height equal in mid number of days. Okay is equals to true. Now I will just try to compensate all the heights with uh, by doing by incrementing one. Okay, for int I is equals to 0, I less than n, I plus plus. If if a of I equals to h, then obviously I would have to continue, no need to perform any operation. Now int d, what is the requirement here? What is the requirement here? The difference itself. Why? Because we have to only increase by 1. So obviously the number of times we do the operation by increment by 1, that would be the number of required operation. Okay, so if again the same thing, if add 1, if add 1 is uh, what I can say, sorry, if add 1 is less than requirement, now this time I can say the requirement is same as the d. Okay, if add 1 is less than d, so we have shortage of 1, so okay is equals to false, and I will break from here, means I can't do the make all the heights same with mid number of days. Okay, else add 1 minus equals to d, and ai plus equals to d, although this was not required. Now finally I will check if I was able to do so, if I was able to make all the heights equal, if I was able, then answer this can be my or answer. Okay, this can be my possible answer. And now I will have to check for the lower possible number of days. Okay, whether I can perform this in minimum number of days or not. Else, if I was not able to do so, then I will have to increase the number of days, as I explained earlier. And after all this, I will just again have to initialize a with thus as it was previously. Okay, now I will just return answer. So that's all about the code. Let's run the code and see whether it is having any compilation error or not. Sorry, I should have included new line character. I forgot to include new line character. Yeah, you can see it has been passed. Okay, 4, 3 and 16. So that's all about the solution, and let's discuss the time complexity. Time complexity is, you can say, big O of n log n, because you are just running for 2 times, and you can ignore that 2n log n number of times to binary search, and n number of times, as in each of these search you are using 2 loops for checking whether you can do that in mid number of days or not. Okay, so it will be big O of n log n. And space complexity, I can say big O of 1, because I am not using extra space. If you count that array, you can count, but if the interviewer asks that what is the space complexity, then you would say big of 1, because you are not using any extra space. Yeah, you are not using any extra space, you are using the same a. Okay, array a. Thank you.